Hey guys, tonight we enter a dying star. You drift slowly through a canvas of black, where even the stars themselves seem to whisper. There's no up or down here, no sound, only the soft glow of distant light and the thick quiet that comes just before something monumental. In front of you, suspended in the void like a lantern with a fading wick, floats a red supergiant, a bloated, trembling elder of the universe, nearing the end of its unimaginably long life. It's so large that if it sat where our sun is now, its surface would swallow Mercury, Venus, Earth, and Mars. But it's not aggressive. It doesn't roar. It pulses, slowly, like an old heart. Trust me, this environment wasn't built with humans in mind, or comfort, or logic. Before we begin tonight's journey of discovery, I just have a small favor to ask. If you're enjoying this peaceful little corner of science, feel free to hit the like button or subscribe so you won't miss any of our upcoming nighttime explorations. It really helps this small channel grow, and it means a lot to me. If you're still awake enough to type a few words, I'd love to know, where in the world are you listening from? And what time is it where you are right now? There's something so lovely about seeing science quietly stretch across time zones, shared together in stillness. I truly hope this story is gentle enough to help you drift off to sleep. But there's always a small risk. It might be too interesting. And if you do stay awake through the whole thing, at least you'll walk away with a bit of new knowledge. And honestly, that's not a bad reason to lose a little sleep. Now, take a deep breath in and slowly exhale. Let's begin. You move toward the star, passing through layers of thinning cosmic dust, each speck older than written language, older than Earth. As you get closer, the light shifts. It doesn't blind you. This isn't a place of sharp intensity, but of slow intensity. The kind that builds and builds, like pressure in a sealed jar, until something must give. The surface of this dying star is mottled and swollen, like the skin of a fruit left out too long. Convection currents rise and fall across its face in vast, slow-motion storms, each one large enough to fit entire planets inside. You could call it majestic, but that would be underselling it. It feels ancient, like it remembers things. Inside, the real story is unfolding. You pass through the outer shell, and strangely, it doesn't feel like burning. The plasma parts around you like a gentle fog. Drawn to motion, it doesn't quite register. You're slipping past heat that would vaporize anything solid. But here, in this guided slowness, nothing hurries to destroy you. Not yet. The layers inside this star are like a cosmic version of a Russian nesting doll, only each layer burns a different element, stacked neatly by how quickly they run out of fuel. On the outer edges, it's still hydrogen, like in our sun, simple, predictable fusion that's kept the star stable for millions of years. But deeper in, you find helium, then carbon, neon, oxygen, silicon, each one fused into the next as gravity demands more energy and the star obliges. Reluctantly, each layer burns faster than the last. What took millions of years in the hydrogen layer now takes thousands, then hundreds, then days, and soon, hours. You reach the core. It doesn't roar or glow. It just presses. You can feel the density in your chest, even though you don't have a body here. Just a sense of proximity, a sense of nearing something final. The core has been burning hotter and faster, stacking elements like frantic Tetris blocks, until one finally breaks the rules. Iron. Here's the thing about iron. It doesn't play fair in the fusion game. When lighter elements fuse, they release energy. That's the secret that fuels every star. But iron doesn't release energy when fused, it consumes it. Building iron in the core is like loading the final straw onto the camel's back. The star doesn't explode because of iron. It collapses because it has no energy left to fight gravity. It's the moment the star gives up. Right now, deep within this bloated red giant, that very process is unfolding. The iron core grows heavier by the second. No new energy flows outward. The balance tips. Scientists still debate whether this exact moment, when the iron core hits its critical mass, is truly sudden, or whether the star begins to grieve long before we ever detect the shift. What's certain is that when it happens, it's fast. Faster than anything that came before. Gravity takes over. The iron core collapses in on itself at a quarter of the speed of light. The atoms are smashed together, electrons forced into protons, creating a wave of neutrons and a massive blast of neutrinos, tiny ghost particles that flood out in a silent scream. But, for now, from where you're watching, the star only trembles. No flash, no bang. Just that slow, failing pulse. You drift back slightly, hovering inside the outer helium shell. It's still burning, still pretending everything is fine. But beneath it, the collapse has already begun. The tension builds like a held breath. There's a strange beauty in this denial, a final performance before the curtains fall, one last round of fusion, one last dance of heat and light. The clock is ticking. You can feel it. Not in any sound. Sound can't travel here. But in the way the particles move. A kind of quiet urgency, like they know something is coming. And so do you. You hover near the outer helium shell, and though it still hums with the quiet rhythm of fusion, the balance is shifting beneath it, a calm surface with a storm brewing just beneath the skin. You know what's coming, even if the star doesn't yet seem to. For a long time, it has kept itself alive through the push and pull of two mighty forces, gravity and fusion. And you're about to feel the moment when that ancient truce finally collapses. Gravity has always been here, always pulling everything inward. It wants to crush. It wants to shrink the star into a point of no return. But fusion, that brilliant, radiant process, pushes back. At the center of the star, lighter elements have fused into heavier ones for billions of years, producing the light and heat that push outward, holding gravity at bay like a carefully balanced breath. But now, fusion is running out of fuel, and gravity is starting to smile. You drift deeper into the dying heart of the star as that tug-of-war becomes one-sided. The outer layers are still oblivious, still gently burning through helium and carbon, but they're floating on a hollow promise. Below them, the core is collapsing. Faster than thought, faster than fear. The atoms that once resisted are now giving way, folding in on themselves like paper under pressure. The pressure rises, not slowly, not politely, instantly. Gravity accelerates. The iron core, once the size of Earth, is now shrinking down to the size of Manhattan. In seconds. You feel it like a punch through the quiet, not loud, not violent, just inevitable. A ripple that distorts everything around it. And then, silence. Not because nothing is happening, but because everything is happening all at once. You've reached the tipping point, the moment where the star is no longer fighting back. Fusion has stopped in the core. There's no more light pushing outward. Gravity, unchecked, begins its collapse. And for the first time in billions of years, the star begins to fall into itself. Outside, nothing seems different. The outer layers continue their quiet burning, but inside, it's chaos. You slip toward the center again, this time faster. You're being pulled, not just by curiosity, but by the sheer distortion of space around you. You're watching matter fold. The atoms compress. Electrons are smashed into protons, and together they form neutrons, particles so densely packed that a teaspoon of them would outweigh Mount Everest. It's a strange kind of violence, silent, elegant, terrifying. You can't see it exactly, but you can feel it. Reality itself feels strained, bent inward, and then, in the midst of collapse, a change. You follow the trail of what scientists call a core bounce. It's what happens when all that collapsing material suddenly slams into a wall, the newly formed neutron core, and rebounds. A shock wave bursts outward like a heartbeat, but it's not enough. Not yet. The shock stalls. It doesn't make it far. It slows, fizzles, falters. For a moment, it seems like the star might collapse entirely, disappear into itself, become a black hole right then and there. But the universe, as it often does, has another idea. And that idea is neutrinos. Trillions of ghost-like particles are created in an instant and flood outward from the core. They are absurdly small, absurdly fast, and absurdly hard to stop. They stream through the star, barely interacting with anything, but just enough to transfer energy, enough to revive the stalled shock wave, enough to make the difference between collapse and detonation. Scientists still debate whether this neutrino heating is the sole trigger of supernova explosions, or just one piece in a messier puzzle. But for you, hovering in this moment, it feels like the breath before the scream, a surge, a deep inhale of invisible energy before everything erupts. You drift upward, back toward the outer shells. The pressure is rising, and the energy within the star is no longer contained. All those quiet layers, helium, carbon, neon, are about to be shattered. You pass through the silicon-burning shell. This layer is the fastest of them all. Silicon fuses into iron in just a matter of days. It's like a last-ditch sprint before the finish line. But that finish line is a cliff, and the star is already airborne. Then it happens. From the inside out, a shock wave reignites. Not the stalled ripple from before. This one is roaring, fueled by neutrinos, guided by physics still not fully understood. It tears upward through the star. You ride alongside it, feeling everything shake, not like an earthquake, more like an unraveling. The outer layers don't resist. They're torn away in a blast so massive that it outshines entire galaxies, not metaphorically, literally. For days or even weeks, this one dying star will pour out more energy than all the stars in the Milky Way combined. But you're not watching it from a telescope. You're inside the moment. You feel the rush of particles, the deformation of magnetic fields, the conversion of matter into energy. You feel the light being born, not sunlight, something more raw, primordial, and strangely, in the middle of all this destruction, there's beauty. The star is dying, yes. But it's not just ending, it's becoming. All those heavy elements, gold, silver, uranium, are forged in these milliseconds. They didn't exist before, not really. You're watching the universe make its rarest ingredients in a final, glorious act of violence. Some of those atoms will fly outward into the interstellar void, eventually drifting for eons until they find their way into new stars, new planets, new things. Some of those atoms might even find their way into you, but that part of the story comes later. Right now, all you can do is float and watch as the core collapses and the outer layers ignite. It's not an explosion the way humans imagine. There's no boom, no fireball, just energy, freed from its long containment, surging outward like a cosmic sigh. You close your eyes, not because it's over, but because there's too much to take in. Light that would fry your cells, particles that have no name, forces that you'll never feel again. And in the distance, the faintest trace of calm begins to return. You drift through the remnants of something that was once whole. The shockwave has passed, the great detonation already unleashed, and now what's left is motion, chaotic, glowing, purposeful motion, all around you. The shattered guts of the star are flying outward. Particles, atoms, strange little specks of history being born. The star didn't just die. It tore itself apart so completely that its fragments are now the building blocks of everything else, including you. You follow a glint of something heavy, a gold atom forged just moments ago in the heart of that nuclear fury. It spins, weightless in the vacuum, oblivious to how rare it is, how many billions of years it will float through space before landing in a ring, a tooth, a satellite, or maybe just never be seen again. Its entire life is a drifting possibility, just like yours. This is where elements come from. Not the hydrogen and helium. Those are the universe's old favorites, made in the first few minutes after the Big Bang. But everything else, everything heavier, it comes from this, from stars that lived long enough to die spectacularly. Oxygen for your breath, calcium in your bones, iron in your blood, even the copper in your old bedside lamp. All of it was born in the moments you're floating through now. The idea that death creates life isn't just poetic, it's literal here. You're watching it happen. The heavier the element, the more violent its creation. You pass through a cloud of platinum atoms, then something stranger, technetium, an element that doesn't last long but somehow still shows up in the atmospheres of certain red giants. Scientists still debate whether technetium is a sign of internal mixing, or if it hints at deeper, more chaotic layers inside stars. Either way, it shouldn't be there, but it is. And now it's part of the great outward rush. You float alongside the flow, moving through layers that were once carefully stacked, like the pages of a cosmic book, but are now flung open in every direction. It's not just a supernova now. It's a supernova remnant, a story being carried outward by momentum and memory. The core has collapsed into something strange, maybe a neutron star, or maybe something darker, more secretive. We'll get to that soon. But for now, the focus is on what's left behind. You drift past silicate dust, still forming clumps. These grains are tiny, but in a few million years they might collide with others, start sticking together, and form the earliest building blocks of a new solar system. Maybe one of them will crash into another and melt. Maybe it'll pick up enough mass to curve space around it and pull more stuff in. Maybe, eventually, something with gravity, spin, and temperature. Something like Earth. But again, that's a story for later. Right now, you move slowly through the debris field, the leftovers of something massive and ancient. Everything is glowing, but not in a loud way. It's like an ember field, suspended in ink, quiet sparks drifting in every direction. Each one holds potential. You pass through a region filled with ionized gas, mostly hydrogen, heated by the explosion, still glowing from the shock. These glowing clouds are what telescopes on Earth might pick up as supernova remnants, outlined in the colorful filaments. You wouldn't know by looking, but inside each filament are atoms moving at thousands of kilometers per second. It's one of the few places where beauty and violence look exactly the same. And then, a surprise, a tiny, dense, fast-spinning object, the core that remained, a neutron star. You approach cautiously, though it isn't dangerous to you like it would be to matter. If you had mass, you'd already be torn apart. The gravity here is so intense that mountains can only rise a few millimeters. The whole thing is about the size of a city, but weighs more than the sun. You can't land. There's no landing. You hover above it, sensing the magnetic field, one of the strongest in the universe. It spins rapidly, emitting beams of radiation from its poles like a lighthouse on overdrive. If you were watching from Earth, those beams might sweep past us every few milliseconds. We'd call it a pulsar, but here, from this close, the spinning is dizzying, not visually, more like a pressure in your mind, a pulse you can't ignore. The neutron star doesn't glow the way the rest of the explosion does. It's quieter, more compressed. It's a leftover, a reminder, a remnant. Sometimes these stars merge, and when they do, they make gravitational waves, ripples in space-time itself. Scientists on Earth detected one of those collisions not long ago. It was brief, faint, and traveled for 130 million years before ringing in our detectors. But it confirmed what was suspected. These explosions don't just make light, they shake the fabric of reality. You stay here for a moment longer, letting the feeling of weightlessness drift into something else, a kind of wonder. You're in the presence of a thing that shouldn't exist, but does, something so compressed that it bends the rules. And yet, it's just part of the cycle, because eventually, this neutron star will cool, it'll stop pulsing, it'll fade into the background of the galaxy, one faint ember among billions, and the cloud of debris around it, that will keep traveling, drifting outward, becoming part of other systems, other futures. You follow one of the particles, a lonely carbon atom, as it exits the growing cloud. It doesn't know where it's going, but it doesn't have to. Time doesn't rush here. There's space to drift. And in the slow ballet of the universe, that's all anything ever does. The carbon atom drifts, unhurried, through the cooling storm. It doesn't shimmer, it doesn't dance. It just exists, small, silent, and infinitely patient. There's no destination yet, only direction. You follow it, not because it knows where it's going, but because there's something calming about its pace, a kind of cosmic nonchalance, like it trusts the universe to figure things out eventually. As it drifts farther from the blast site, the density of the debris begins to thin. The echoes of the explosion fade into background starlight. What's left behind is a cloud, an expanding sphere of gas, dust, and newly forged elements, stretching outward for light years. This is no longer just the aftermath of a death. It's the beginning of something else, a nursery in disguise. You pass through the layers of this newborn remnant, watching particles settle into strange patterns. Some clump together, jostling and bonding. Others glide alone. The star's onion-like layers that once burned so neatly are now smeared across space like a painter's brushstroke. But even in this chaos, you can sense an order forming, not imposed, but emergent. Gravity still works here. Time still ticks, slowly, delicately. The pieces begin to arrange themselves, somewhere, far beyond where your vision stretches. Other stars are watching, not with eyes, but with gravity. As this cloud expands, it will bump into one of them. Maybe not tomorrow, maybe in 1,000,000 years, but eventually. And when it does, the interaction could compress part of the cloud, stir it, warm it, wake it up. That's how new stars are born, from pressure and patience. You float deeper into the cloud now, past filaments of gas that glow with residual heat. The hydrogen here is everywhere. It's the most basic stuff, the first child of the Big Bang and the raw material of stars. But mingled among it are the treasures of the supernova: oxygen, nitrogen, carbon, iron, silicon, phosphorus, all the ingredients you'll eventually need for oceans, bones, and breath. Not that they know that yet. You pass through a denser knot of gas and dust. It's swirling, slightly, tugged by distant forces. Nothing is moving quickly here. Nothing ever does, at this stage, but it's enough. Enough to start pulling things in. Gravity doesn't need speed, only time. You watch as the gas begins to flatten, forming a disk. Not a planet, not yet. Just a shape, a preference, a hint. The outer edges slow, the inner regions begin to spiral. The middle thickens, the temperature rises, pressure builds. And without fanfare or fireworks, fusion begins again, quietly, in the dark. A star is born. You blink, or would, if blinking mattered here, and realize how familiar it all is. This new star isn't special. It's average, mid-sized. It doesn't roar. It hums. It doesn't shine with glory, just with constancy. But that's what makes it perfect. It will live for billions of years, slowly burning its hydrogen, gently lighting its corner of the galaxy, and around it, a disk of debris begins to cool. You move through this new protoplanetary disk. It's messy, chaotic. Not yet planets, but ingredients in motion. Particles collide, stick, shatter, and collide again. Dust becomes pebbles. Pebbles become rocks. Rocks become mountains. It takes millions of years for anything meaningful to happen, and even then, the meaning is subjective. But here, among these floating clumps, something is changing. One rock gets lucky. It attracts others. Gravity builds. It clears its path. It grows hot inside from collisions. Eventually, it rounds itself into a sphere, a planet, still molten, still wild, but real. And here's the twist. This is familiar. It has the right distance from the star, the right spin, the right wobble. It catches comets and retains an atmosphere. Water condenses, rain falls, rivers form, life begins, quietly, invisibly, in the shallow warmth of some distant pool. You're not watching Earth, not necessarily, but it might as well be, because this isn't just a story of one dying star. It's a pattern, a rhythm. Stars live, die, and seed the next generation. The elements forged in their final moments don't disappear. They become rainstorms, mountains, lungs, and thoughts. Maybe even dreams. You pause in the disk, hovering near a grain of dust that will never be part of a planet. It will stay in orbit for a while, then spiral into the star, vaporizing without ever having become anything. But that's okay. Not every atom is destined for greatness. Some just pass through the story, quietly. You keep drifting, this time toward a different part of the cloud, a place still lit by shock waves, where new stars are beginning to flicker into existence. You pass a red dwarf, barely burning. It will outlive almost everything. Then a massive blue star, short-lived, dramatic, and destined for another brilliant ending. This whole region is a tapestry of time. Stars at every stage of life, young, old, forming, dying. It's not a graveyard, it's a garden. Things don't just end here. They recycle, rearrange, restart. Scientists still debate whether there's an ultimate beginning or end to this process, whether entropy will win in the end, stretching the universe into stillness. But, for now, in this little pocket of light and motion, the cycle feels unbroken. You take a long, slow pass through the newborn cluster of stars. Each one carries within it the legacy of the supernova you just witnessed, not its ashes, its intention. A spark passed down, not consciously, but fundamentally. A trace of energy moving forward through time. You turn, briefly, to glance back, though back has little meaning here, at the empty space where the supernova happened. It's already fading. The shock waves have thinned, the glow is dimmer, and yet it lingers, like a scent, like a story you don't quite remember, but still feel something from. You keep going, not because you're chasing anything, but because the universe always moves, even when it sleeps. You drift farther now, letting the soft pull of the galaxy guide you. The stars behind you twinkle faintly, like a quiet crowd watching from afar. You're moving through a region that no longer remembers the supernova as a singular event. To everything here, it was just one in a long list of transformations. Stars explode, dust scatters, time passes. That's how it's always been. And now, you find yourself inside another star. Not a young one, not a dramatic one, just steady, a quiet middle-aged star that's been burning patiently for billions of years. It's not flaring or trembling or showing off. It's just doing its job, converting hydrogen into helium, one fusion reaction at a time. You wouldn't notice it from far away. You'd probably call it average. But here, inside its core, things are anything but boring. Fusion is happening all around you. Hydrogen atoms slamming together under immense pressure, overcoming their natural urge to repel each other and merging into helium. Each fusion releases energy, a spark, a photon, a bit of light that's been waiting since the dawn of the star. These photons don't rush out in a beam. They stumble, they bounce, they ricochet from particle to particle, moving in the slowest, most indirect game of cosmic pinball you've ever seen. Some of the light you're watching right now, it might take 100,000 years to reach the surface. Let that sink in. The light being born in this moment, in the core where you float, will spend thousands of centuries bumping into atoms, changing direction, losing energy, softening, becoming redder, before it finally escapes and shines into the void. And when it does, someone somewhere might call it sunlight. They might grow plants with it, read a book by it, feel its warmth on their face and not think twice. But here, inside the furnace, it's just begun. You rise slowly through the interior of the star, letting yourself be carried by radiation pressure. The layers here are calm, deceptively so. The convection zone above you churns quietly, with currents of hot plasma rising and cooler matter sinking back inward. It's like the surface of a pot that never boils over but never stops moving. It's not chaotic. It's organized motion, predictable turbulence, the kind of activity that sustains instead of destroys. Scientists still debate whether the exact boundaries between these zones are as crisp as our models suggest, or whether the star's internal layers are more like overlapping conversations, blurred and blended. Either way, the result is the same: a stable star, burning steadily, aging quietly. You finally reach the surface, and everything changes. There's no edge to cross, just a thinning, a soft fade from dense plasma to stellar atmosphere. And then, just like that, you're outside. The light that struggled for 100,000 years finally escapes beside you. It doesn't scream. It just flows, golden, diffuse, a sigh that's been held in for too long. And the surface? It's not smooth. It's textured, like a field of boiling oatmeal. Sunspots form and vanish. Magnetic loops rise and twist. Flares occasionally lash outward, brief flashes of stellar frustration. But even those feel muted here, tamed, like the star knows how to keep its tempers short. You float just above the photosphere now, surrounded by light. It's not hot, at least not in the way you'd expect. You feel the effect of heat more than the sensation, an energy, a pressure, a deep hum that resonates through everything. The photons around you are only seconds old now, free from their long journey, zipping off in every direction. And that's when you remember something important. This isn't just a peaceful star. This is a prelude, because eventually, even quiet stars like this one will run out of hydrogen. Even they will grow old. Their cores will contract. Their envelopes will swell. Their color will shift, redden, deepen, and someday, this calm, steady burn will give way to something much more dramatic. This one just isn't there yet. You turn your attention to the star's outermost breath, the solar wind. It's a soft stream of particles, flowing outward like a breeze you can't quite feel. It travels far, touches planets, carves tails in comets, shapes magnetic fields. You follow it for a while, letting it carry you, past the corona, where the temperature strangely rises instead of falls, past the orbit of whatever planets might circle this sun. Out into the solar system, it governs. Out here, space feels emptier. The warmth fades, but never completely. The memory of the star stays with you, a kind of golden echo. You pass a frozen chunk of ice, a comet, asleep in the outer reaches. It hasn't felt heat in millennia, but one day, the star's gravity will pull it in. It will wake, sublimate, grow a tail. For now, though, it sleeps in a quiet so complete it might as well be timeless. And just as you begin to wonder where you'll go next, a flicker catches your eye, not from this star, but from a distant point of light far beyond. Another star. But this one is different. It pulses, not like a heartbeat, but like a beacon, a steady rhythmic flash. You move toward it, drawn by curiosity, and as you get closer, you realize it's not alive in the traditional sense. It's not burning fuel anymore. It's too dense, too strange. You found a pulsar. For now, you linger in the glow of the middle-aged star, letting its calm energy wash over you. It hasn't exploded. It hasn't collapsed. It hasn't made gold or death or drama. It has simply been, and somehow, in all that simplicity, it's made room for life. You leave behind the warm, balanced star, that gentle furnace with its patient burning and golden light. and let the distant flicker guide you. The light isn't wavering, it's regular, precise. You follow its rhythm, a cosmic metronome ticking steadily through the dark. It's almost soothing until you realize how fast it's pulsing, dozens of times per second, maybe hundreds, whatever it is. It's not like the star you just left, it's something entirely different. You're getting closer now. The pulses resolve into sweeping beams, tight cones of radiation, rotating with clockwork precision. You're watching a spinning remnant, a relic of something that once was a massive star but is now compressed beyond recognition. You've arrived at a pulsar. This star doesn't shine like others. It doesn't radiate gentle warmth or give off light in every direction. It shoots out beams from its poles, narrow and intense, like twin searchlights on a turntable. You're not seeing the whole object glow, only catching those beams each time they pass across your position, like a lighthouse glimpsed through fog. That's why they blink, not because they stop shining, but because they spin. You move closer and can finally make out the object itself. It's tiny, shocking, really, maybe 12 miles across, about the size of a city, but it contains more mass than our sun. It's spinning so fast it would make you dizzy if you had a body. Hundreds of revolutions every second. All of this, from something the size of a modest town. You try to wrap your mind around it, but your mind politely declines. The surface, if you can call it that, is rigid, smooth, and impossibly hard. It's not made of atoms as you know them. The matter here is packed so densely that the protons and electrons have fused into neutrons. It's a ball of nuclear matter, a single, massive atomic nucleus spinning in the dark. Some call it a neutron star. You can't argue. Occasionally, the star hiccups. Not metaphorically. It literally stutters in its spin. These are called glitches. And they happen when the star's crust adjusts under the strain of its own gravity. Imagine a mountain suddenly shifting by half a millimeter, and that tiny twitch being felt across light years. You're witnessing one now. A pause in the perfect rhythm, a single, sharp adjustment. Then the spinning resumes, indifferent and relentless. Scientists still debate whether these pulsar glitches are caused by shifts in the crust or interactions with a superfluid interior. Yes, a superfluid, a form of matter that flows without friction, spinning silently within this hyperdense object. It's one of those details that doesn't make much sense, but also doesn't go away. The universe often works like that. You orbit the pulsar now, just outside the reach of its lethal magnetic field. The field lines twist and flare, stretching out like cosmic ribbons. If you were made of matter, this place would tear you apart. But as an observer, you're immune. You just watch. And there's plenty to see. The beams of radiation aren't just light. They're packed with energy, particles, information. They sweep across the galaxy like Morse code from a ghost. Earth-based astronomers study them with massive radio dishes, using the regular pulses to test theories of gravity, time, and space itself. Some pulsars are so precise that they rival atomic clocks. Others drift ever so slightly, evidence that they're slowly winding down, spending the last of their rotational energy over millions of years. But you're not measuring anything. You're just floating here, letting the rhythm of the pulses settle into you. It's easy to get lost in the repetition, not hypnotized exactly, but stilled. The galaxy can feel noisy sometimes, even in silence. But this This is a heartbeat. You look around and realize something else. You're not alone. Not in the living, breathing sense, but in the debris. The space around this pulsar is littered with the faint outlines of what used to be its parent star, a slowly expanding halo of gas and dust, faded and fraying at the edges, the remnants of the supernova. You're floating inside the afterglow of an event that reshaped space around it. This region is called a pulsar wind nebula, a kind of haunted cloud where particles from the pulsar crash into the leftover material from the explosion. It's chaotic, but also somehow delicate. Particles race and spiral. Magnetic fields twist them into beautiful arcs. Some of these shapes could stretch across light years, but from here, they just look like brushstrokes in the void. You drift through one now. A ribbon of charged particles loops above you. It doesn't move fast. It doesn't make a sound. It just is. And you realize that even though the supernova happened long ago, its echo still sculpts the space around it. In the far distance, you spot something new, fainter than the pulsar's beams, smaller than the debris field, but stranger. It's a flicker, subtle, almost ashamed of itself, but it's there, something deeper, darker, and far more final. You can't help but wonder, but you're not ready to go there yet. Not just yet. You circle the pulsar one last time, tracing the arc of its beams as they pass. You imagine them sweeping across Earth, across distant telescopes, across the minds of people who stay up late thinking about time and motion and the edges of what can be known. The pulsar won't notice you leaving. It doesn't care. It doesn't need to. It will keep spinning, faithfully, for another 100 million years, slowing down 1 microsecond at a time, until eventually, it, too, will fall silent. But for now, it pulses, and you follow that steady beat outward into the waiting dark. You drift away from the pulsar's embrace, its precise rhythm slowly fading behind you. The galaxy stretches out ahead, endless and quiet again, but not empty. There's always something just beyond, another light, another mystery, another version of collapse or rebirth waiting in the dark. You follow the faintest flicker now, one you noticed before but couldn't name. It doesn't pulse or shine. It pulls. This isn't a light you can chase. It's a gravity you can feel. You're headed toward a region where light itself bends inward, where even time doesn't behave the way you expect it to. The pull gets stronger the closer you move, not suddenly, just persistently. A slow, irresistible draw. And as you near it, the stars around you seem to smear and stretch, not because they're moving, but because space is. You've arrived at a black hole, but not just any black hole. This one was born from a massive star, much larger than the one that formed the pulsar. A star so heavy that even its neutron core couldn't hold itself up after collapse. The pressure was too great. There was no bounce, no rebound, no rescue by neutrinos, just a free fall into itself until it passed the point of no return, the event horizon. You don't fall in, not yet. You hover at the edge, just outside the boundary where escape becomes impossible. From here, the black hole doesn't look like a hole. It looks like a distortion, a place where background stars curve around a center that refuses to show its face. There's no surface, no glow, just a gravitational silhouette. You move closer, staying just outside the line that defines forever. Light from nearby stars arcs toward the horizon, spiraling inward, growing redder and slower. Some of it bends around and escapes, some doesn't. Time begins to feel strange here. It stretches, slows, slips. You don't notice it all at once, just gradually, a kind of temporal numbness. Scientists still debate whether time actually stops at the event horizon or just appears to from the outside. From here, it feels like both. You float in a place where 1 second could be an hour, or a century, or an instant, if you were to cross the line. But you won't. Not yet. Instead, you watch. Around the black hole is a disk, a swirling plane of superheated gas and matter spiraling toward doom. This is the accretion disk, and it's far from quiet. It glows with X-rays and heat, formed from the desperate friction of matter being torn apart. If the black hole is silent, the disk is its scream. Particles in the disk race at incredible speeds, orbiting hundreds of times per second. They compress, stretch, shred, all the while losing energy, inching closer to the edge until they vanish entirely. Some of them never quite fall in. They hover near the edge, doomed to spin forever until some final nudge seals their fate. You drift just above the disk now, letting the heat wash through you without burning. There's motion here, but also clarity. Patterns emerge, spiral arms, shock waves, tiny eddies in a sea of destruction. It's chaos with choreography. And you realize, even destruction follows laws. Every now and then, something escapes, not whole objects, but jets, streams of plasma that shoot out perpendicular to the disk. They blast away at nearly the speed of light, cutting through space like galactic spotlights. No one fully understands how these jets form, but they do. Like the black hole's way of venting its excess. A breath, if it can be said to breathe. You follow one of these jets for a while. It's long, unimaginably so, thousands of light years, extending far beyond the galaxy's heart. But eventually it dissipates, particles spreading out, losing energy, becoming just more background noise. You turn back to the black hole, still there, still devouring, still unseen. Somewhere inside, matter has vanished, not destroyed, exactly, just changed, compressed into something that defies all known understanding, a singularity, a point of infinite density, hidden forever behind the veil of the horizon. No one knows what it's like in there, and if they do, they don't come back to tell us. You float near the edge now, still resisting the temptation to cross. But you do wonder, what would it feel like? Not physically, since you're not exactly physical anymore, but perceptually. Would time vanish? Would you see the entire universe collapse into a pinpoint above you as you fell inward? You let that question linger, not because it needs answering, but because it reminds you that some mysteries remain intact, even after all we've learned. And then you feel something new, not a pull this time, but a pressure, a ripple in the fabric of space itself. It's faint, subtle, but unmistakable. A gravitational wave. It didn't come from this black hole. It came from two others, far away, colliding in the dark. You can't see them, but you can feel the tremor, like the soft quake of distant thunder. The universe just shifted, ever so slightly, and you were here to notice. Scientists on Earth have built instruments to catch these ripples. Massive laser setups with mirrors so still they can detect distortions 1,000 times smaller than a proton. When they first caught a wave, they knew immediately what it was. The ghost of a collision. Proof that space isn't a backdrop, but a participant. You drift in the afterglow of that ripple, letting it pass through you like a whisper. It doesn't change you, but it reminds you that nothing, not even space, is perfectly still. You look one last time at the black hole. Its hunger is endless, but it's not evil. It doesn't choose. It simply obeys gravity to its final extreme. You turn away, leaving it to its silence. There are more stars waiting, more endings, more beginnings. You float through a quieter corridor of the galaxy now, far from the violence of black holes and pulsars. The stars are more spread out here, the background dimmer, the silence deeper. It feels like the edge of something, not a boundary, but a breath, a place between stories, between pulses. And just when you begin to settle into the calm, you notice something almost too faint to see, a flicker, a blur, not a star, not quite. You drift closer, curious. It's not glowing brightly. It's not tearing space apart or collapsing in on itself. It just sits there, soft and dim, a dying ember among the galactic fire, a white dwarf. You've arrived at what remains when a smaller star, like our own sun, finishes its long, quiet life. It never exploded. It never screamed. It just let go, slowly, layer by layer, until only the core remained. That core cooled, contracted, and settled into what you see now, a sphere no bigger than Earth, but with half the mass of the sun packed tightly inside. It looks calm, but that calm is deceptive. You drift toward the surface, though you'll never quite touch it. If you were made of matter, you couldn't. The gravity here is enormous. A teaspoon of this star would weigh as much as a skyscraper. The atoms have been stripped of their identity, squeezed so closely together that the pressure keeping them from collapsing comes not from heat, but from the raw resistance of electrons refusing to share space. Electron degeneracy pressure, as scientists call it. It's the last act of resistance before collapse. And here, it works, for now. You orbit slowly, watching the faint shimmer of thermal radiation. The star is still hot, incredibly so, but with no new fuel to burn. It's just cooling, bleeding off heat over billions of years. It won't flare. It won't fuse. It will simply fade. Scientists still debate what happens in the very long run. Given enough time, and we're talking longer than the current age of the universe, a white dwarf may cool so thoroughly that it becomes a black dwarf, a cold, dark lump of degenerate matter, invisible and inert. But since the universe isn't old enough yet, not a single black dwarf exists. They're a future phenomenon, a whisper of what's to come. For now, white dwarfs shine faintly, quiet lanterns at the end of a peaceful path. You notice something odd, though, a companion star nearby, small, close, orbiting fast. This isn't just a lonely white dwarf. It's part of a binary system. And as you watch, the companion begins to lose matter, drawn away by the white dwarf's intense gravity. Gas spirals inward, forming a swirling disk around the dwarf, glowing brighter as it falls. And then, a flash. Not a supernova, not the kind you've seen before. This one is stranger, smaller, more sudden, a nova. When enough gas from the companion star piles onto the white dwarf's surface, the pressure and temperature ignite runaway fusion, not in the core, but on the surface. A burst of energy, a temporary brightening. The white dwarf flares like a match struck in darkness, then settles back down. You float through the remnants of this eruption. The gas is still expanding, still warm, but the star survives. It doesn't die. It just throws off the excess, breathes a little lighter, and returns to its slow, inevitable cooling. You pause here, letting the moment linger. You've seen stars explode violently. You've seen matter collapse into near infinity. But this is different. It's subtle, measured, a kind of patience that feels ancient, a kind of resilience. You wonder how many of these are out there, quiet stars that once burned bright, now dimming gently through time. They don't get as much attention as black holes or neutron stars, but they're everywhere. Dozens, hundreds, maybe billions. The quiet majority of stellar ghosts, glowing softly while the galaxy spins on. And as you drift farther, another possibility forms in your mind. A white dwarf with a heavier fate. Not all of them remain stable. If enough mass falls onto a white dwarf, from a companion, from debris, from collision, it can be pushed past a critical threshold, the Chandrasekhar limit, about 1.4 times the mass of our Sun. Beyond that, electron degeneracy pressure isn't enough. The star can't hold up, and it collapses, not into a neutron star, not always. Sometimes, instead of collapsing inward, the whole star detonates outward in a thermonuclear explosion, a type Ia supernova, no iron core required, just carbon, oxygen, and too much mass. You pass one such remnant now, the ghost of a white dwarf that couldn't resist. The explosion was symmetrical, powerful, and bright. So bright, in fact, that scientists use these specific supernovae to measure the expansion of the universe. Their brightness is consistent enough to be used as cosmic yardsticks. You drift through the outer edges of its remains, still glowing, still spreading. Somewhere in this debris field are particles that will someday be part of something else. Maybe even another star. The cycle loops again. You continue on, leaving the dead dwarf and its remnants behind, moving toward a part of the galaxy where the light grows faint again. The quiet returns. The stars here are sparse, fewer voices, longer silences, and yet the story continues. You begin to wonder how many generations of stars have come and gone before this. How many exploded, cooled, collapsed, merged, or simply faded. How many times this galaxy has recycled its own atoms into new forms, and how many more it has left to go. You drift through the thinning edge of the galaxy, where the stars are sparse and the spaces between them grow wider, quieter. Everything here feels old, not ancient like ruins or fossils, older than that. This is the kind of old that belongs to dust itself, the kind that makes you wonder how long light can travel before forgetting where it came from. And it's here, in this deep hush, that you feel something unexpected, a kind of recognition, because even though you're surrounded by silence, something about this place feels familiar, not in form or structure, but in content. You realize, slowly, that you're not just surrounded by the aftermath of stars. You're part of it. Every bit of material you followed, the hydrogen, the helium, the carbon, the oxygen, the iron. These are the same elements that make up the human body. You are stardust, literally. The calcium in your bones, the iron in your blood, the nitrogen in your DNA, all forged in stars that died long before Earth was even a thought, long before this galaxy had its current spiral arms. You float among your ingredients, scattered through time and space, before they ever assembled into skin and thought and language. It's humbling, and a little funny. If the universe had a user manual, it might just be burn, collapse, scatter, repeat, and occasionally wonder. You approach a faint cloud now, not a star, not a remnant, but something more primordial, a molecular cloud, rich in hydrogen and helium, touched with traces of carbon, sulfur, and silicon, cold, dark, vast, the birthplace of stars and, eventually, life. Not because it tries to be, but because that's what gravity and time do when no one stops them. You enter the cloud slowly. There's no boundary, only thickening. The starlight dims until everything is filtered through fog. Not gray fog, but deep blue-black. A velvet kind of dark. Inside, the gas is barely above absolute zero. You can feel its stillness. Hear the faint vibration of molecules so cold they move like tired dancers, slow and deliberate. And then, a twitch, a clump. It's tiny. Just a slightly denser patch in the cloud. But gravity notices. It starts to pull. More molecules drift in. The clump grows denser, heavier. Its own mass becomes its invitation. This is how stars begin, not with fire, but with falling. Over thousands of years, the collapse continues. The clump flattens, spins, forms a disk. The center thickens, pressures rise. You drift inside the growing core, where hydrogen atoms start to bump elbows. At first, they just jostle, but the jostling increases. At some point, no one can say exactly when, fusion begins. And there it is, a new star, born not with a bang, but with a whisper, a soft glow in the dark, a point of warmth in a sea of cold. But this star is different. Around it, the disk remains, dust, rock, ice, the leftovers, and just like before, the disk starts to clump, not into one ball, but many. Some melt, some collide, some grow big enough to pull in gas and become giants. Others remain small, stony, and resilient. You know what you're watching. The early chaos of a solar system, the origin of planets. One of them draws your attention. It's rocky, wet, still forming, bombarded daily by comets and meteors. Its crust is cooling, volcanoes bubble, the surface is unstable, but the conditions are, improbably, just right. And in one warm, shallow pool, or maybe a vent deep in the ocean floor, chemistry begins to flirt with biology. Molecules tangle, structures form, some replicate, most fail, but a few succeed, and succeed again. Life. You hover in the thick atmosphere, watching lightning fork through the clouds. Raindrops fall onto stone that was once molten. The air is dense, the sky tinted with strange colors. And yet, this is the beginning. A few molecules here will find the right rhythm. A few will persist. And from that, eventually, everything, this planet might not be Earth. It might never form cities or telescopes or bedtime stories. But it could, and that possibility alone is enough to make you pause. You drift upward again, through the clouds, back into space. The new star glows below, still young, still shaping its orbiting family. In a few billion years, it might host something remarkable, or it might fade quietly. Its planet's cold and empty. The universe makes no promises, but it offers the raw materials, generously. And you float onward, realizing how many times this has likely happened, how many stars have lived and died to make way for new ones, how many chances the universe gives itself to try again. It's not wasteful, it's persistent, always collapsing, always expanding, always reaching for what's next. Scientists still debate whether this persistence means something, whether the universe is fine-tuned for life, or life is just the inevitable result of time, pressure, and luck. But from here, it's easy to believe in patterns. And one of those patterns is you. You've come full circle now, from the collapse of a star, to the birth of elements, to the drift of atoms, to the slow assembly of life. You've followed the long arc of becoming, and though you've watched it unfold from a distance, it feels strangely personal, because it is. After all, the stars didn't just make the world around you, they made you. You drift for a while in silence, suspended between memory and matter. The young star behind you continues its quiet burn, unaware of the life it might someday nourish. The molecular cloud is slowly dissolving, its dark arms stretched thin by starlight and solar wind. What was once a cradle for stars is now returning to the void, a job well done. And you begin to wonder not just about beginnings, but about time itself, not as a ticking clock or a calendar page, but as a thing with shape, with rhythm. You've seen how stars burn through it, some slowly, some in a blink. You've seen how light can take thousands of years just to leave a star's core, how a gravitational wave can ripple through the fabric of space-time and arrive on Earth carrying the signature of an event billions of years ago. Time isn't just something you measure, it's something you live inside. And right now, you're drifting into a region where that relationship starts to blur. Ahead of you lies something strange, not a star, not a planet, not even a black hole. It's a cluster of stars, densely packed, spinning around a shared center of gravity. A globular cluster, old, very old. You pass into it slowly, feeling the stars crowd closer, like lights on a chandelier. There's something peculiar about this place. These stars were born before Earth, before the sun, before almost everything you've seen. They orbit one another in slow, ancient dances. Their light is steady, unwavering, older than language, older than continents. And here, time bends differently, not because of black holes or singularities, but because of gravity and velocity. You glide near the core, where the gravitational pull is strongest. The stars move faster here, packed tightly, tugging at space itself. Time slows down slightly, just enough to notice if you're watching closely. If you were living here, really living, you'd age just a little more slowly than your twin, floating in a quieter patch of galaxy. Scientists still debate how clusters like this form. Some think they're remnants of smaller galaxies absorbed by larger ones. Others believe they are the ancient cores of systems that never quite made it to full galactic scale. Either way, they are fossils, not of stone, but of motion. They remember the early universe not in memory, but in momentum. You watch a blue straggler star flicker nearby, bright and young-looking, out of place in a sea of elderly giants. It shouldn't exist. It's too youthful, too energetic. And yet, here it is. The leading theory? A collision. Two smaller stars, long past their prime, merged into something new. A kind of stellar do-over. A second chance at shining. You drift past it slowly, wondering how many other stars have found ways to survive, to shine again, to rewrite their story after everything should have ended. You're beginning to see it everywhere now, not just the birth and death of stars, but the transformation between the two. The ways the universe refuses to stay still, refuses to stay the same. You move outward again, leaving the dense heart of the cluster and coasting toward the quieter edges. The stars thin out. The space between them grows wider. And then, just as your senses begin to settle, you feel another ripple. This one isn't from an explosion or collapse. It's from motion, a deep, slow swirl in the galaxy itself. You're approaching the spiral arms of a galaxy, not the one you came from, but another, a neighbor. It stretches out ahead of you like a vast pinwheel, turning ever so gently. You hover at the edge, watching entire star systems drift past like glitter caught in syrup. It doesn't spin fast, galaxies never do, but the rotation is relentless. It sculpts, it organizes, it carries. You move along the arm, following its curve like a lazy river. Here, time feels fluid, measured not in seconds, but in revolutions, galactic years. It takes our sun about 230 million Earth years to make a single lap around the Milky Way, and it's only done that about 20 times since it was born. Imagine that. 20 years in galactic time, that's all, and yet. Look at everything that's happened. You drift past nebulae now, clouds of dust and gas lit from within by young, hot stars. They glow pink and violet, sculpted into strange shapes by stellar winds and radiation. One looks like a hand, another like a dragon. You know they're illusions, shaped by light and distance. But even illusions have weight when they make you pause. You slip between two bright stars that orbit each other, circling like dancers tethered by gravity. Their light pulses in alternating rhythms, a slow duet that's been playing for billions of years. You wonder if their paths will ever change, if one will expand and swallow the other, or if they'll spin like this forever, never touching, always near. The galaxy is full of partnerships like this. Stars, moons, particles. None of them move alone for long, and neither do you, because everywhere you go, time follows, stretching, warping, looping, but always there. You've seen it move faster and slower, seen it get tangled in gravity, twisted in light, and now you see it for what it is, not just a measure, but a medium. You are swimming in it. Scientists still debate what time is, whether it's fundamental or just an illusion, whether the past and future are real, or whether only the present exists, whether the arrow of time is set in stone, or just a product of entropy doing its slow, inevitable work. But out here, you don't need the answer. You just float, one moment at a time. You continue floating through the spiral arm of the galaxy, your path tracing lazy arcs between stars that burn in long, measured lives. Everything here feels stretched, not just distance, but time itself, like a song playing one octave lower. You move with the galaxy's slow spin, turning through a silence that seems older than sound. The dust, the light, the starlight itself, all of it flows together in a kind of rhythm you can't quite name, but can almost feel in your chest. Somewhere far behind you, a star just finished forming. Somewhere ahead, another is about to die. You're in the middle of everything, not in space, but in sequence. This is the place where all the beginnings and endings blur together. You pass a quiet system, a pale star orbited by rocky planets and frozen moons. Nothing dramatic, no signs of life or movement, but still, you pause. Because even here, in this quiet, overlooked corner of the galaxy, time is working. Dust is settling. Rock is heating and cooling. Craters are forming. Ice is cracking. Change is happening, even in stillness. You drift closer to one of the rocky planets. It's covered in impact scars, its surface old and worn. But you notice something strange, faint traces of magnetism. a slightly lopsided orbit, a core that might, just might, still be molten. The planet isn't dead, not completely, it's just sleeping, and you realize not everything that looks still is finished. You rise again, leaving the silent world to its long hibernation. Up here, among the stars, time moves in geological sighs and planetary heartbeats. You've started to notice them now, the subtle beats, the small pulses. Everything is breathing in its own way. You glide past another star, this one swollen and red, a giant, near the end of its life. It expands and contracts like it's remembering something. Each pulse sends out a breath of stellar wind, stripping away the outer layers. The star is unraveling itself slowly, turning mass into light and light into space. It's not a death, not yet, just the prelude. You follow a stream of that stellar wind, watching as the gas cools and drifts. It moves in ribbons, in curls, as if the star is exhaling stories it's no longer strong enough to carry. You pass through them gently, like walking through someone else's dreams. Not far ahead, you see the shape the star is becoming, a planetary nebula. That's the name we gave it, even though it has nothing to do with planets. A bubble of color, softly glowing in the dark, lit from within by a tiny, exhausted white dwarf, the last breath of a small star. The colors shimmer, blues, greens, reds, not solid, not sharp, but gentle, fading like watercolors on parchment. And inside, that dot of white, the star that used to be, still hot, still glowing, but winding down. You float through the nebula slowly, letting the light wrap around you. It's not blinding, it's comforting. The way a candle flickers before going out, but somehow warms the room more than it did before. Scientists still debate how these shapes form, why some look like wings or eyes, or glowing shells, whether magnetic fields sculpt them, or binary companions stir the gas into spirals. But no one argues with their beauty. Even the most skeptical observers can't help but stare when they appear in telescopes. They're proof that even an ending can be breathtaking. You leave the nebula behind, turning toward the broader sweep of the galaxy. A deeper thought lingers now, something slower, heavier. What happens when all the stars go out? Not just one, not just this cluster or this arm, but all of them, the entire galaxy, the whole sky. It's not a fantasy, it's a question of time. You imagine it now, billions of years into the future, when stars no longer form because the gas has run out. The bright ones die first, quickly, spectacularly. The smaller ones last longer, cooling into red embers. Eventually, even they go dim. And what's left? White dwarfs fading into black dwarfs, neutron stars spinning slower and slower. Black holes, still waiting, still pulling, but no more light, no more fire, just motion, just mass, just memory. This is what scientists sometimes call the heat death of the universe, a time when everything is so spread out, so evenly distributed, that nothing interesting can happen anymore. No energy gradients, no reactions, no change. Entropy wins. But here's the part no one talks about enough. That takes an incredibly long time. Trillions upon trillions of years. Time enough for stars to live and die, for galaxies to merge, for planets to rise and fall and rise again. Time enough for possibilities. Time enough for you. You look out across the galaxy now, seeing it not just as it is, but as it was, and as it will be. A living spiral, full of light and fire and shadow. turning slowly, so slowly. It barely seems to move, but it does, always. You begin to understand something simple and staggering. Everything you've seen, all the stars, all the dust, all the strange physics and quiet mysteries, none of it stands still. Not really. Even the things that seem frozen are moving through time. Even the smallest particle drifts forward, pulled along by the arrow of change. And so do you. You drift on, not because you have a destination, but because the universe doesn't wait. It doesn't pause. It doesn't repeat. It simply continues, folding, stretching, singing softly in the voice of gravity and light. And if you listen closely, you can almost hear it. Not a clock, not a metronome, but a rhythm, a heartbeat. You drift in that rhythm now, not riding it, not resisting it, just moving with it. It isn't fast, it isn't slow, it's simply there, humming beneath everything, the stars, the gas, the dust, the emptiness, all of it moving to the same cosmic tempo. A tempo not set by any clock, but by the rules of space itself, a rhythm not of seconds, but of structure, of cause and effect. And here, in this moment of stillness, you realize you're not just watching the story of stars, you're watching the story of energy. Everywhere you look, energy is moving, sometimes fast and bright, like a supernova, sometimes soft and stretched, like the glow of a white dwarf fading into the dark, but always moving, always transforming. It can't disappear, it just changes form. You follow a faint trail of infrared light now, the leftover warmth from a cloud of gas heated long ago by a cluster of newborn stars. Those stars have drifted apart since then, but their heat lingers, their energy echoes. The cloud still glows, not visibly, but in longer waves, waves that can be felt if you know how to look. You move through the cloud, noticing how the heat clings to denser regions, warming them just enough to keep molecules dancing. Not violently, not quickly, just enough. It's like the universe is whispering encouragement, coaxing matter into possibility. Eventually, even this warmth will spread too thin to stir anything. But not yet, for now. It's enough. Enough to hold potential. Enough to keep the dance going. You pass out of the cloud and into a more familiar stretch of space. Stars here are spaced far apart, floating like candles in a vast cathedral. And in between them, nothing. Not empty, exactly. Space is never truly empty, but quiet, sparse, like the silence between notes in a song. And then, something catches your attention. A ripple. Not in space. Not like the gravitational waves you've felt before, but in time. A rhythm that doesn't match anything else. It's small, irregular, almost shy. You move toward it slowly, curious. It leads you to a world, not a bright one, not famous, just a modest rocky planet orbiting a middle-aged star. It doesn't seem special at first, but as you get closer, you notice something extraordinary. Patterns, not natural ones, not the elegant spirals of galaxies or the chaotic flows of plasma. These are deliberate, intentional, shapes carved into valleys, lines cut through stone, architecture, roads, cities, civilization. You pause above the planet, letting the sight settle in. You're not looking at a place where stars are born or where atoms fuse. You're looking at what happens much, much later, when matter gains awareness of itself, when stardust begins to wonder where it came from. It's nighttime on the planet now. The sun, just one of billions, has set. and tiny artificial stars begin to blink on below. Streetlights, windows, signals, a quiet web of light that stretches across continents. Faint compared to a supernova, but perhaps more unlikely. This is energy made conscious. You float lower, watching as people move through their lives, unaware that every breath they take is composed of atoms older than their world, that their thoughts are powered by energy forged in a star's dying breath, that their cities run on laws set into motion before there was language, or music, or sleep, and yet they wonder. They study the skies, build telescopes, launch satellites, send signals. They write books and make theories and whisper into the dark, hoping someone or something is listening. Some of them believe they're alone. Others hope they're not. You drift above a dark sea now, watching the waves move under moonlight. On a beach below, someone lies awake, staring up, thinking about the stars, maybe for the first time, maybe for the 1,000th. They don't know you're here. They don't know their body is built from recycled explosions. But somehow, part of them does. Because they wonder, and wondering is a kind of gravity. Scientists still debate how life begins, whether it's rare, a statistical miracle, or inevitable in the right conditions. Whether consciousness is an accident of biology, or something the universe stumbles into often, like a habit it can't quite shake. But down there, on that quiet world, it happened. A planet, warmed by a small star, gave rise to awareness, to curiosity, to storytelling. And in those stories, they try to trace their way back through evolution, through chemistry, through stars and galaxies, until they reach the beginning, or try to. Some stop at the Big Bang, others go further, but all of them, carry a quiet truth. They are not apart from the universe. They are the universe, looking at itself, thinking about itself, trying, in its own fleeting way, to understand. You rise again, leaving the planet behind. It grows smaller, dimmer, until it's just another speck in a sky full of specks. But you don't forget it. You can't. Because for all the stars you've seen, all the collapses and bursts and fragments of light, that world holds something rare, a memory, not the kind stored in atoms, but the kind built in stories, passed down, shared, shaped. The universe has many ways of remembering itself: supernova remnants, nebulae, gravitational waves, and, now and then, a small planet with creatures that ask questions and dream under stars they'll never reach. You drift on, quieter now, touched by something you didn't expect, a kind of hope. Because if the universe can build stars, and then bodies, and then minds, and then questions, maybe it's not just burning, maybe it's becoming. You move quietly now, as if not to disturb the thought. It clings to you, soft and persistent. The idea that the universe isn't just a series of events, but a kind of unfolding, not mechanical, but expressive, not static, but reaching, and somewhere, in that reaching, life happened, memory happened, consciousness happened. The stars did not merely scatter matter, they scattered the possibility of meaning. You drift away from that planet, not in distance so much as in time. The starlight around you begins to blur, not from motion, but from age. The spiral arms behind you dissolve into a slow haze. You're entering a future that hasn't quite been built, at least, not yet. And everything here feels quieter, like the echo of a room after a concert has ended. Stars are fewer now. You pass a red dwarf still glowing, slowly, stubbornly. These stars live the longest. They don't shine with grandeur, they flicker with patience. Their light lasts for trillions of years, and in the far-flung chapters of cosmic history, they'll be the final beacons. You hover near one now, feeling its warmth, not hot, just steady. A hearth in a deepening winter. Around it, a few planets still circle, tightly, closely, their orbits slow and deliberate. One is tidally locked, always showing the same face to its sun. One side in constant day, the other in endless night. Somewhere along the edge, the Terminator line, there might be life. Not like the kind you saw before, slower, stranger, adapted to the twilight. You won't know. You're not here to study. You're just passing through. And yet, the thought lingers. Life always finds the edge, the in-between, the margin where forces meet and balance. It doesn't need ideal conditions, just enough conditions, time, chemistry, and a chance to try again. You continue. The galaxy fades behind you now, not in brightness, but in cohesion. The arms loosen. The stars drift farther apart. Gravitational bonds weaken over billions of years. Interactions slow. Collisions grow rare. The stars that remain do so quietly, cooling, dimming, sighing into the dark. Eventually, you reach the intergalactic void, the space between galaxies. It is vast in a way that resists comparison. You could fit dozens of galaxies in the emptiness here and still feel alone. But even here, there's structure. Threads of dark matter connecting the cosmos like a hidden web, shaping the paths galaxies follow without ever shining themselves. You ride one of these threads now, invisible but definite. The galaxies cluster in its grip, not tightly, but intentionally. The universe is still expanding, still stretching like taffy. Space itself isn't just empty, it's growing, and as it does, these clusters move apart, faster and faster. Eventually, distant galaxies will slip beyond reach. Not because they move quickly, but because the fabric of space pulls them away faster than light can bridge the gap. One day, an observer in the far future may see only their own galaxy, all others redshifted into oblivion, a lonely island in a dark ocean. But that day is not yet here. You approach a cluster now, one of the last great gatherings of galaxies. Dozens, maybe hundreds, spinning slowly around a shared center. They dance not with grace, but with gravity, pulling, distorting, tearing bits from each other. Some galaxies are full spirals, still alive with star formation. Others are elliptical, pale and tired, with stars so old they barely shine. You slip past the edge of a collision, two galaxies mid-merger, their arms tangled, their cores drawing close. This is no violent crash. It takes hundreds of millions of years. Stars rarely hit stars. The drama is slow, inevitable, beautiful. Gas clouds compress, starbursts flare, and then silence. Eventually, the galaxies settle into one, a swollen ellipse. The new stars live fast. The gas runs out. The light fades. You pause to consider something strange. This merger you're watching might someday be the fate of our own galaxy. Scientists still debate when, but they agree that the Milky Way and the Andromeda Galaxy are on a collision course. Not now, not soon, but someday. They will meet, they will blur, they will become one. And in that future galaxy, the remnants of suns long gone may still orbit quietly. Their planets, if any remain, will circle faded cores, unaware of the name of the sky they look up at. History, even cosmic history, will be rewritten in shape and silence. You leave the cluster behind, farther still, farther into a future where light is less common, where black holes roam, having swallowed the last bright embers of matter. You pass one now, cold, vast, quiet, not roaring, not growing, just waiting. Occasionally, one of them evaporates, slowly, painfully slowly, through a process called Hawking radiation. They leak energy into the void. It takes longer than the current age of the universe, but eventually, even black holes die. Scientists still debate whether that's truly the end, whether the information inside is lost forever, or somehow encoded in the fading radiation. The laws of physics seem to argue about it, and no one has yet won. You float near the fading edge of a black hole's life. It's no longer massive, no longer terrifying, just there, a whisper of its former self, a story dissolving into background, and then it's gone, not with a bang, not even a flicker, just absence. You wait. Nothing replaces it. But the universe doesn't stop. It never does. Even in this deep future, with stars extinguished, galaxies thinned, and time stretched nearly to stillness, there are still particles, still photons, still motion, however small. The great engine hasn't stopped. It's just quieter now. Like a fire burned down to its last glowing coal. You drift through that quiet. You are not lost. You are not alone. You are the story still being told. The silence now is deeper than before. Not empty, never empty, but stretched so wide that even echoes seem to forget what they were responding to. You drift farther into the darkness, the kind that hums softly with background radiation, the last whisper of a much younger universe. It's faint now, cold, diluted almost beyond recognition. But it's still here, the afterglow of the Big Bang, stretched into microwaves, washing over everything. You move through it like a ghost, listening, not for voices, just for presence. The cosmic microwave background doesn't speak in words or shapes. It speaks in uniformity, a signal so evenly spread across the sky that it almost says nothing at all. And yet, that nothing is filled with meaning. This is the light from the time when the universe became transparent, when it cooled enough for atoms to form, for photons to travel freely. It's the first light, still wandering, still announcing, gently, that everything came from somewhere. You pass through it quietly, watching as it fades even further. The universe keeps expanding, and as it does, this ancient radiation stretches, reddens, dims. Someday, it may be undetectable, lost not because it vanished, but because the tools used to catch it will no longer exist. Or perhaps because no one will be left to look. And yet, you keep drifting, not because you're seeking something new, but because even here, in the furthest stretches of time, there is still motion. Ahead of you, something glints, not with light, but with curvature. A ripple in the otherwise flat canvas. You draw closer and see it, a lonely object tumbling in space, small, dense, familiar. It's a rogue planet, torn from its solar system long ago. It now floats through the intergalactic dark, unbound. No sun warms it, no moon orbits it. And yet, it endures. Wrapped in a thin, frozen atmosphere, it carries traces of its origin. Ice clings to shadowed craters. Subsurface oceans may still slosh beneath a crust of quiet rock. You hover near it, and for a moment, you feel something tender. This is not a star. It's not dramatic or grand, but it's resilient. It's what's left when gravity lets go. A drifting chapter in a book most readers have already closed. You follow the planet for a while, watching it spin gently. It doesn't speak, but its presence says everything. It is a vessel of memory, a remnant of worlds that once danced around stars. And maybe, just maybe, one of those underground oceans still holds warmth, enough for chemistry or life or something in between. You drift on again. The stars are almost gone now. Those that remain are ancient red dwarfs or cooling remnants, quiet embers flickering at the edge of time. Their light barely registers against the black. You pass a white dwarf so cold it no longer glows. It's not dark, not entirely. It's just quiet in a way that light no longer interrupts. Scientists still debate how long it would take for one of these stars to become a black dwarf. Some say longer than the current age of the universe by a factor of hundreds, maybe thousands. Time so immense it begins to lose its distinction from eternity. You pause here, letting the stillness settle. If the universe had a twilight, this would be it. The golden hour has long passed. The silver dusk has faded. And now, there's only the deep, soft blue of something that isn't over, but is no longer beginning. And still, particles move. You follow a neutrino now, one of the most elusive particles in the universe, born in the core of some ancient star. It's been flying through space for billions of years, passing through galaxies, planets, even you. It rarely interacts. It simply continues, as if motion itself were its only truth. You try to match its speed, not to catch it, but to witness what it sees. Its path is straight, unbroken, unworried. It doesn't know what it was part of. It doesn't care, but its existence is a promise that something, somewhere, still is. Even now, even here. You drift alongside it until you both pass through an empty void so complete it nearly erases sensation. And yet, in this silence, you feel something returning. Gravity, not strong, not sharp, but patient. You're approaching something massive, not bright, not loud, but unmistakably present. A black hole again, but this one is different. It's old, older than any you've seen. It has swallowed stars, gas, light, maybe even other black holes. It's grown massive, not because it rushed, but because it waited. Everything that came too close, it kept. And now, it waits still, surrounded by almost nothing, a monument to consumption in a universe that has nothing left to give. But even it cannot last. You wait nearby, letting time stretch. Slowly, imperceptibly, it begins to leak. Through quantum mechanics, through Hawking radiation, it loses mass, not visibly, not obviously. Just eventually, scientists still debate what remains when a black hole dies. Is the information inside lost forever? Or is it smeared across its event horizon, waiting to be translated by physics we don't yet understand? Here, there's no answer. Only slow release. And eventually, even this too is gone. You remain. Not because you're immune to time, but because the story isn't finished yet. The universe is almost dark now, not cold, not quite, but nearing stillness. Energy is spread thin, stars are gone, galaxies are shadows. What remains is dust, particles, long wavelength radiation, and a few quiet whispers of gravity. But even here, even now, Motion continues, and you drift with it, not because there is somewhere to go, but because there is always somewhere to be. The universe hasn't ended. It's just begun speaking more softly. You glide farther into the hush, where even the silence seems to rest. The last great black hole has faded behind you, leaving no flare, no mark, no farewell. It simply completed its sentence. And now, you move through a universe that is neither chaotic nor empty, but balanced at the edge of quiet persistence. What remains is subtle, thin clouds of low-energy particles, lone photons redshifted into near oblivion, occasional relics drifting like forgotten notes at the end of a long song. There's no warmth here. Not really. The background temperature has dropped to just above absolute zero. The last of the cosmic microwave background has been stretched into invisibility. But even this cold is not total. Even here, the universe holds a flicker, the barest hum of continued existence. You pause beside a loose cluster of particles, ancient, slow, each with its own long memory of motion. They don't bind together, they don't build, they simply pass, brushing past each other in the dark. There are no more stars to pull them in, no gravity wells to trap them, just the open drift of entropy, the universe finding its lowest possible energy state, like water spreading across a flat plain. And still, there's structure, not obvious, not architectural, but patterned, fluctuations in the density of virtual particles, quantum jitters, a low-frequency murmur running through space itself, like the crackle of a vinyl record long after the music has ended. You float through it slowly, feeling the texture of what's left. Scientists still debate what comes next. Some argue that this is the true end, a universe where everything runs down, where energy is too diffused to do anything interesting, and nothing ever changes again. Heat death, total thermodynamic equilibrium. Others wonder about quantum decay, the idea that even the vacuum of space isn't stable, that one day, somewhere in this vastness, a sudden event might rewrite the laws of physics themselves. A new vacuum, expanding at light speed, transforming everything it touches, not an explosion, a replacement, a different version of reality, rippling outward, and some suggest a rebirth, that somehow, in the distant future, a new Big Bang might emerge from the quiet, not a continuation, but a restart, a fresh beginning from the ashes of all that came before. You don't choose between them. You simply float, watching the universe as it is. The structure that once defined everything, galaxies, stars, molecules, is gone now. But there's something poetic in its place, not chaos, not order, just stillness, like the final page of a book left open, long after the reader has gone. And in this stillness, you begin to reflect. You remember the first star you saw, the red supergiant, trembling at the edge of collapse, the shock wave, the neutrinos, the gold atoms flung into space. You remember the neutron star, spinning like a pulse, the black hole, folding light around itself, the white dwarf cooling in the dark, the clouds of dust reborn into planets, the flickering cities on distant worlds, the person looking up at the sky, wondering. You remember all of it, not as a list, but as a feeling, a kind of awe that lives behind language, a gratitude so large it never needed to be said aloud. And most of all, you remember that everything, absolutely everything, came from something simple, a balance between gravity and fusion, between time and temperature, between expansion and collapse, between silence and song, you drift on, gently, following a trail of long-wave radiation, not because it leads anywhere, but because it reminds you that motion still exists, that even here, at the end of the universe, there is something to feel, a continuity, a rhythm that started before stars and persists even now, without audience, without urgency. Eventually, you come across something unexpected, a structure, not made of matter, not carved from gas or dust, but something else, a fluctuation, a ripple in space-time, like a wrinkle frozen in the fabric of what remains. It's not large, it doesn't glow, but it pulses, very faintly, not with energy, but with possibility. You float closer. It's a remnant, not of matter, but of form, a curvature in space that remembers how things used to be. Like the groove in an old record, it carries the shape of a song. Even if the instruments are gone, you let yourself sink into it, slowly, carefully, and for a moment, the pattern becomes clear, not an image, not a map, but a motion, a kind of memory written into the very curvature of space. And then it fades again, but the feeling stays. This isn't the end of the universe. It's just the furthest you can follow its breath, the quietest verse in the longest lullaby. And even here, you are not outside the story. You are the story. Because the atoms that once made you, the thoughts, the breath, the warmth, all of them came from stars that lived and died in the great cosmic rhythm. You are not visiting the universe. You are the universe, remembering itself. And even if the stars go out, and the black holes fade, and the galaxies dissolve into a sea of dark, that memory stays. Because it happened. Because you happened. You move on, not towards something, but with it, the way a note fades into silence, or a breeze drifts through open air. No destination, no finale. Just the long, slow unfolding of what is. And even now, in this soft ending, something begins. It might be small, it might be distant, but in the deep cradle of stillness, a fluctuation stirs, and with it, the suggestion of a new story. You turn toward that suggestion now, not because it calls to you with urgency, but because in a universe this quiet, even a whisper feels monumental. The fluctuation is barely there, like the memory of a ripple after the water has gone still, but it moves. And in this distant future where everything else has settled, motion, any motion, feels like a revolution. You approach it gently. There is no glow, no fanfare, just a localized region where virtual particles seem to gather, jittering with a kind of collective tension. Space bends here, not much, just enough to notice. A pocket of curvature in a landscape that has otherwise flattened, not enough to trap light, not enough to form anything yet, but enough to make you pause, because it feels familiar. Not like a place you visited, but like an echo of something deeper, a pattern you felt before, a rhythm that once led to stars. You drift closer, tracing the slow swirl of quantum instability. The fluctuation isn't alone. It's part of a field, subtle variations in energy, spread across the quiet cosmos like seeds scattered on frost. And this one, for reasons you can't see, is beginning to grow, not fast, not visibly, but steadily. It curves space just slightly more than it did before. A ripple nested inside a ripple, not enough to collapse, but perhaps, eventually, enough to tip. You've seen what happens when pressure builds quietly, when a cloud cools, when gravity listens to its own weight. collapse is never sudden. Not really. It begins in silence, in stillness, with nothing more than imbalance. And then it finds momentum. You hover beside this forming anomaly, sensing its internal tension rise. There's no explosion, no tear, just a shift, a point where probability no longer shrinks, but begins to grow. The vacuum, once stable, begins to slide towards something new. And then it begins, not with sound, not with light, but with inflation, an expansion of space itself, faster than the speed of light, not through it, but with it. This isn't a thing moving through the universe. This is the universe, growing from inside itself. You don't travel through it. It grows around you, enveloping, stretching, becoming. You're inside a new beginning, and it is nothing like the one before. This time, the rules may be different. The constants may change. The symmetry may not break the same way. Particles form, or fail to, based on conditions you can't predict. But the rhythm is still there, under everything. Expansion, cooling, clumping. You recognize the pattern even if the instruments have changed. A new universe. Scientists still debate whether this could happen, whether a bubble of new physics might spontaneously emerge and outpace everything else, not in destruction, but in replacement. A new vacuum swallowing the old, a fresh page in the book with a different grammar. And here you are, watching the first words being written. You hover within this young space as energy condenses into fields, and fields collapse into particles, quarks, gluons, maybe, or maybe something else. You don't recognize all of it, but the intent is the same. Structure forming from heat, from motion, from imbalance. The universe remembers how to make things. Time hasn't fully settled yet. Space is still stretching. But already, you can feel the beginnings of gravity taking hold, of matter defining shape, of light finding its way. You move slowly now, passing through a place that is no longer empty. It's not full either. It's pregnant, rich with potential. You feel energy pooling into clouds, clouds compressing into filaments, and filaments threading themselves into clusters. You've seen this before, but never like this. Because this time, you're not just observing a rebirth, you're realizing something deeper. This has always been part of the story, not a sequel, not a separate universe, but a continuation, a new verse in an endless poem. You begin to understand that maybe there was never truly an end, only a pause between pulses. Maybe the universe is less like a novel and more like music. And this is the next measure. You follow a forming star now, its core still a soup of chaos, its edges undefined. But already, fusion is waking up. Hydrogen finds hydrogen. Light sparks in darkness. Again. Around it. A disk spins, irregular, uneven, but you know what comes next. Dust clumps, rock forms, and somewhere, on some unremarkable piece of stone, perhaps warmth will gather, maybe molecules will dance, maybe, again, something will wonder. You float upward, away from this one moment, knowing there will be others, new galaxies, new stars, new chances, and with each, the possibility of memory, of questions, of stories. Scientists still debate if the universe is cyclic, if expansion leads to contraction, or if new beginnings truly emerge from the old. But from here, that question feels smaller than the motion itself. The universe doesn't owe us an answer, it just keeps going, and so do you. Through clouds of probability, through dust shaped like dreams, through the slow, certain heartbeat of everything becoming something again. You pause one last time in this newly forming cosmos, letting the warmth of its first stars brush across your awareness. They are young, unformed, imperfect, but they shine anyway. And somehow, that's enough, because the universe, against odds, against entropy, against silence, continues to make light again. You remain suspended within this newborn cosmos, as if time itself is holding its breath. Around you, energy condenses in eddies, swirling into clumps that haven't yet decided whether to become particles or waves. Everything is uncertain here, but not in a fearful way. It's the kind of uncertainty that invites creation, the kind that says there are still stories waiting to be told. You follow the early filaments of matter as they stretch and tug across space. Gravity is already weaving its quiet architecture, forming invisible bridges where galaxies will one day bloom like lanterns in fog. You drift along one of these embryonic threads, watching as gas thickens into nodes. Even without stars, these knots glow faintly with the memory of potential. You pass through a pocket of dense radiation, just beginning to cool. The energy here is fierce, untamed, but it's slowing, expanding, relaxing. The frantic heat of the universe's earliest moments is giving way to something more structured. The sound of the cosmos, those primordial pressure waves that ripple through the plasma, is beginning to fade. And in its place, silence is forming again. Useful silence, creative silence. You feel it before you see it. The first atoms forming. Protons catch electrons. Neutrons find partners. And suddenly, the chaos becomes chemistry. Hydrogen and helium dominate. But scattered here and there are trace whispers of lithium. Delicate, fleeting, almost embarrassed to be included in the mix. It's not much, but it's enough. Enough to start with. You drift between these new atoms, light and free, not yet bound by the rules that will later govern stars and galaxies. For now, the universe is in its blank page era, unwritten but not empty. Everything you've seen, everything that was, has been stripped down to the essence, and from that essence, something new will rise. Already, clouds of gas begin to collect. You've seen this before, countless times, but it never feels the same, because each time the universe builds itself again, it improvises. The core notes are familiar, but the arrangement shifts. Maybe this time, the constants are slightly altered. Maybe gravity falls just a bit more softly. Maybe light curves a fraction more slowly. Maybe that's enough to change everything. And yet, the first stars appear anyway. You catch one just as it ignites. A blue-white blaze in the dark, hot and hungry. These are population 3 stars, the first of their kind. They burn quickly as die violently. There are no metals in them yet, no carbon or oxygen or iron. They're made only from hydrogen and helium, and they are enormous, fragile in their own grandeur. You follow one as it expands rapidly, burning with a ferocity that suggests it knows it won't last long. These stars don't form planets. They don't host quiet solar systems. They are fireworks, not hearths, but they are necessary. Because in their death, in their supernova, they will create the first heavy elements, the first building blocks for everything that comes next. They are the cosmic blacksmiths, forging future stardust in their final breath. You hover near as one of them begins to collapse. It doesn't mourn. It doesn't hesitate. It simply yields to gravity's final demand. folding in on itself with all the grace and terror of inevitability. A shockwave bursts outward, new elements are born. Space is stained with gold, silicon, carbon. For the first time, the universe has the ingredients for breath, for bone, for language. You feel the wave pass through you, and you follow it outward into the aftermath. The gas doesn't flee, it clumps, it swirls. The enriched cloud gathers around the scar left by the dying star, and before long, more stars begin to form, smaller now, more stable, cooler, kinder, and this time they come with disks. You circle one such disk, drawn in by its slow, spiraling grace. Dust collides and clumps, pebbles grow, moons begin to form even before planets do. You watch one particularly heavy object clear a path in the disk, sweeping through like a quiet sculptor, rounding itself into a perfect sphere. It's too early to say what kind of world it will become. Maybe it will remain barren. Maybe it will become an oceanic haven. Maybe it will never cool enough for life to find purchase. But the possibility is enough. The fact that it can happen again, that the universe is willing to try, is enough. You move from world to world now, not staying long. A frozen orb reflects the starlight like a cracked mirror. A gas giant hums with magnetic storms. A rocky moon dances so close to its parent that tidal forces warm its hidden ocean. None of these are Earth, but they don't need to be. They are places that can host wonder, and that's always been the point. You remember now the planet you left behind in the old universe, the one with streetlights, books, stories, and sleepers beneath a soft sky. You remember its gentle hum of cities, the quiet whir of thought, the flicker of consciousness trying to make sense of the stars. And here, in this new universe, you find yourself wondering again, not just whether something like that will happen again, but how. Will there be thinkers made of carbon, or perhaps something else? Something we wouldn't even recognize as life, or mind, or story. Maybe the rhythm of curiosity will still rise, no matter the form. Because if the universe has a nature, it may be this: to reach from hydrogen to memory, from chaos to meaning, from expansion to reflection. You drift higher, watching a new spiral galaxy begin to take shape in the distance. Its arms are uncoiled, its core bright. It spins like a thought forming. The stars within it will live and die and seed new beginnings. And somewhere in one of those arms, eventually, light will fall on stone. Molecules will stretch toward complexity. And someone, will look up and ask, "How did we get here?" And if they listen long enough, the stars might answer. You follow the spiral arm of the new galaxy as it unfurls slowly across the dark. A graceful swirl of stars barely formed. Gravity pulls gas into ever-tightening threads, weaving brightness out of nothing. The core glows faintly, wrapped in a gentle haze of dust. It's young, the whole galaxy, but already you can see the outlines of what it will become. Clusters forming, orbits stabilizing, light organizing into structure. From a distance, the spiral shape is soothing. It doesn't scream for attention. It turns slowly, gently, like it has all the time in the universe, because it does. You drift toward one of its arms, passing early stars scattered like glowing punctuation marks on the page of space. Their colors are soft, their light a little uneven, still finding rhythm. Some pulse in long waves, others flare unpredictably, newborns trying to settle into the rules of fusion. Below, new systems are forming. Dust circles light, pulled into thin, flat disks. Some of these will make planets, others will remain debris, ice, stone, wandering fragments. You pass one such disk and watch as its center grows brighter, a star, just beginning to wake. It pulses faintly with the breath of fusion, not confident yet, but steady enough. The disk around it is thick with possibility. You move through it slowly, weaving between icy clumps and molten rocks. Tiny collisions spark silently. Some bits stick, others scatter. It's not fast. Planet formation never is. But already, you can feel the subtle pull of larger bodies coalescing. Gravity is always sculpting, quietly, persistently. You pause near one growing mass, a rocky planet just starting to pull itself into shape. It wobbles with each impact, layers forming under pressure and heat. You watch its surface cool, then fracture, volcanoes swell, rifts open, steam escapes. It's violent, but necessary, a kind of cosmic growing pain. Further out in the disk, icy moons form around a gas giant. Their orbits settle into harmonious patterns. A few are too cold, too far, but one, hugging the edge of warmth, catches your attention. Beneath its frozen crust, tidal forces stir an ocean, water, motion, heat. You don't know what will come of it, but the ingredients are here. You drift higher, rising above the system. Light from the young star filters through clouds of dust. The planet and its moons circle below, small but persistent. And for the first time in this new universe, you feel something familiar, potential. Not guaranteed, not certain, but real. You move on. Through the arm of the galaxy, the density of stars begins to grow. Some are old already, fast-burning giants doomed to brief lives. Others are stable, quiet, ready to host something more. Around one, you notice rings of debris forming intricate spirals, signs of gravitational nudges from unseen worlds. You follow these curves like trails, letting them lead you to a planet in formation. It's not like Earth. Its atmosphere is thick and amber. Lightning flickers beneath its clouds, but it rotates with purpose, and the chemistry brewing below could become something remarkable. You can almost feel it, molecules linking, breaking, linking again. And you remember, it doesn't take much, a shallow pool, a vent on the ocean floor, a drop of water warmed by starlight. That's all it ever took to begin the long, slow rise of life. Not complex, not immediate, just persistence. Over time, repetition becomes pattern, pattern becomes function, function becomes memory, and memory becomes story. You drift low over this world, through the top of its thick clouds. You can't see the surface, but you don't need to. You can feel the energy flowing, the tension of potential. It doesn't matter whether this is the place. What matters is that a place exists, a chance, a crack in the dark wide enough for light to enter. You stay a while longer, listening to the low thunder rumble through the sky. There's music in it, in the timing, in the weight, in the way it rolls across the air like a thought still forming. It's not music for ears. It's music for presence, for noticing, for understanding, even without words. Eventually, you rise again. The planet shrinks beneath you. The star grows faint. The spiral arm curls on, filled with futures that haven't happened yet. You follow its length toward the edge of the galaxy, where the stars are thinner and the dark stretches deeper. It's quieter here, softer, and yet you feel something stirring. Not a particle, not a planet, but a possibility. You hover in that feeling, a place where, someday, someone might stand on a rocky shore and look up at the night sky. They won't know the story you've just watched. They won't remember the collapse of the old universe, the fading of light, the silence of black holes, but their atoms will, because those atoms, those particles, that dust, were there. They will be made from the first stars of this new cosmos, from the gold that was born in stellar death, from the carbon that once danced in fire, from water that once flowed in oceans beneath ice, from light that wandered the universe before there were names for anything. And when they look up at their sky, they will wonder, they will ask questions, they will build stories out of starlight and gravity and time. Maybe their science will look nothing like ours. Maybe their thoughts will move in patterns we can't imagine. But they'll ask, because that's what matter does. When it remembers where it came from, you begin to move again, slower now, as if not to wake something sleeping. The galaxy keeps spinning, the stars keep forming. The rhythm you first felt at the edge of collapse has returned, not louder, but wider. It's no longer just the rhythm of motion, it's the rhythm of memory. And if this universe continues, and it will, that rhythm will grow. It will fold into stars, into planets, into stories, and maybe, just maybe, into someone who tells it all again. And now, you begin to drift, not toward anything in particular, not away from anything either, just drifting, the way dust drifts in a shaft of sunlight, the way a thought meanders just before sleep. You've seen the universe bloom and fade and bloom again. You've traveled through gravity and starlight, through silence and fire, through the long, unfolding echo of time, and still, it continues. The galaxies you visited spin on without you now. The stars you watch being born are warm in their first orbiting stones. Somewhere in those distant forming skies, a faint light is falling across a quiet sea. No one is there yet to see it, but someday, someone might be. And if they are, if they wonder, they'll feel what you feel now, a kind of gentle awe, not the loud, blazing awe of discovery, but the softer kind, the awe that doesn't shout, the kind that whispers, like a breeze through trees, like a star just before it shines, like a memory you're not sure you lived, but somehow still know. So you let yourself sink into that feeling, the way the universe folds and unfolds, the way matter becomes memory, the way silence always makes room for one more story. You're not separate from that rhythm. You are that rhythm. And if you're still here, still listening, still breathing slowly through the dark, you've become part of the long, long lullaby, a note held gently in a song older than time. So now, let go. Let the questions rest. Let the stars keep watch. Let the warmth of the story stay with you, not as a lesson, not as an answer, but as a hum beneath your thoughts. Sleep well, traveler. The universe is still singing. End of script.